Okay, for the node voltage analysis, we need to recall back again the KCL or the Kirchhoff current laws. Okay, now I'm going to show you, just recall what is the KCL, because this one we're going to use in the node voltage analysis, alright? So, in definition, KCL is actually the algebraic summation of the current at node, and the summation of current will be equal to 0 lah. Okay, or we also can define KCL as the summation of currents entering a node is equal the summation of current leaving a node. So that's the equation for KCL. Alright, okay, so I'm going to give you an example. What is when the KCL, the summation of current, which is equal to 0 or equal to 0. Okay, and then we also use this convention lah. Okay, so this convention we use it is easy, if we use it, then it's easy for us to make an equation lah for this node voltage lah. Okay, for example, so I'm going to use this convention for this example. All right, so for example, if you have this node, let's say you have this V1 node, all right, and then you have this current. Let's say this one is I, this one is I2, and this is the I3. So the entering, if you look at here, the entering is actually positive, right? So this one going to be positive, and the leaving here, the leaving will be negative lah. So this one is positive because entering this node and entering this node lah. So for the equation, I always like to do this lah, positive and negative, right? So for the positive sign, what you will have to do, you can just add it like I1 plus with I2 equal with I3 for the positive sign convection, which is I3 lah. Okay. Okay, and the important things that you also need to know for the node voltage analysis is that the important is that you need to know the control current, lah, for the branch or the node. Okay, so like for this one, since we use the signs convection, right, for the positive and negative, which is positive when you have the node is entering and when you have the node is leaving, so you can just put it as a negative lah. Okay, so the choice we make for the voltage polarity determines the directions of the current arrow lah. So alright, so the current arrow points into the positive signs of the resistor voltage lah. So usually this arrow is actually referred to this positive sign for this resistor lah. Alright, okay, so this is very important lah for you to note lah. Alright, so okay, so like for this example, what I'm going to show you. Okay, so if you are given this circuit, all right, so what you have, how can you determine the voltage across the resistor, current through the resistor, and also the power of the current source? So this one you can determine by using the node voltage lah. Okay, so like for this one, for this example, you have actually two node, okay, which is you have node 1 and node 2 lah. Okay, so this one you can just write it as V1 and V2 lah. So this one we call it as a non-reference node, and this one, which is the ground here, we call it as a reference node lah. Okay, so for this one we have V1 here and V2 lah, so means that we have two nodes. And note that if we have the two nodes, so means that we need to have two equations for the to solve the voltage lah for this node, which is V1 and V2 lah. Okay, so like for this example, okay, so this node 3 is actually defined as a reference node, as I said before, and node 1 and node 2 is labeled as V1 and V2 here lah. Okay, so now we need to calculate this node voltage, which is V1 and V2. So now before we calculate the node voltage, first like I said before, we need to know the current directions. Alright, the current directions for each of these branch lah, like this node and this node lah. What is the current directions before we have the equation for this circuit lah, in order to solve for V1 and V2. Okay, so what we have here is, okay, like for this example, all right, so this is the current direction that you must first choose before you come up with the equations lah. Okay, I'll always like to use this lah, which is the positive, enter the node, negative, which is exit the node lah. All right, so like for this one, we have this V1 here, so now we need to focusing on this V1 node, and then you can see that how many current that we have here, which is we have I1, I2 and I3. So this one we need to make sure whether it's entering or leaving the node in order to come up with the equations. Okay, so like if I just draw this node back again with this V1, so I know that I1 is actually entering, so I just put it positive, and I2 here is leaving, so I just put negative. Same with I3 also leaving, so I just put negative lah. So then I can come up with the equation. So the equation is actually, we have I1, which is entering, which is positive and negative. All right, so you just need to sum the positive and negative sign. Okay, so like for I1, it's just only one you have, but for the entering, only one you have, which is the I1, and for the leaving, you have these two, I2 and I3. Just sum that lah. Alright, so you have I1 equal to I2 plus I3 lah. Okay, and then after that, you need to come up with the, this current. What we have is we need to use the KCL. You know that KCL is the current. So current is actually I equal to V over L, right? This is by using the Ohm's law lah. So means that in order to get the I, what you have to do is you need to voltage divide by the R. I equal to V over R. So V equal over R. Okay, so you need to come up with this equation lah. Okay, so I1, obviously you already have it like 5, right? As a 5, so just put it here 5, and then equal to I1, I2. I2, you know that here V1 minus, just follow the arrow here. If your arrow here, so you need to use V1 first. So if your arrow is coming right here, so you just have to use V2 minus V1. But here, because your arrow is coming through these directions, so V1 minus with V2 over 4, this R. Okay, V over R. This is for your current lah. Okay, so what you have is, like for this one, obviously V1 minus V2 over 4 for I2, and your I3 is actually V1 minus with 0 here over 2. So you have this. So now you need to simplify this equation. How to simplify this equation? What you have to do is you need to kill this denominator, right? So to kill this, you need to times everything with 4. So you will get 20 equal to V1 minus V2 plus with 2V1, right? And then when you simplify, what you get is 20. Here you will get 3V1 minus with V2. So this is your equation. Okay, let's say this is your equation 1 lah. Okay, And then after that, you have another node. You have another node at node V2 lah, like this one. Alright, you have this node V2. Alright, for this node V2, obviously you have 4 branch of current lah. Okay, so you have I1, I2, I5 and I4. So let's say here, so for this node V2, I5 is actually leaving, I5 is leaving, and then I1 is leaving, I5 is leaving, and I2 is entering, then entering. So just sum up everything with, this is actually positive convention and this is negative lah. So obviously for positive, I2 plus with I4, and then for the negative, I1 minus with I5 lah. Okay, so then after that you need to come up with this equation for I using this. All right, so I1 and I2, so obviously I2, the directions of current is here, right? So V1 minus V2 over 4, and then for I4, obviously it's already 10, the current, right? And for I1 is already 5, and this I5 is here. So means that V2 minus 0 over 6. V2 minus 0 over 6 lah. Okay, so you just have to sum up everything, just equate everything. Then you need to simplify. Again, when you need to simplify, you need to kill this one, this 6 and 4. And then how to kill this 6 and 4? What you have to do is just times with 24 and then do your math, and then you will get, when you simplify, then you get this equation lah. Okay, so how can you solve for this equation 1 and equation 2? All right, so let me show you. You can use the simultaneous equation method, where you can use the elimination method, and also you can use the substitute method lah. All right, also you though you have only 2 equations, so you can use the matrix solution, where you can use the Cramer rules, right? So the solution for this one, which is V equal to 13.33 and V2 is equal to 20 volts lah.